Welcome to this video on SQL Materialized Views. Today, we're going to explore how materialized views can significantly speed up your queries and improve database performance. We will be understanding materialized views for faster queries. So, what exactly are materialized views? A materialized view is a database object that contains the results of a query. Unlike regular views, the results are physically stored as a copy of the data. This copy of data is not automatically updated when the source tables change. This is a key difference that we'll explore further. However, they significantly improve query performance for complex queries that are run frequently. Consider a scenario with multiple tables, such as an orders table, a customers table, and a products table. A complex SQL query is run on these tables, and the result is stored in a materialized view. This allows for faster access to the data, as the query does not need to be re-executed every time the data is needed. Let's compare materialized views to regular views to understand the key differences. Regular views are virtual tables that do not store data. The query executes every time the view is accessed, and it always shows the most current data. This approach is slower for complex queries that are run frequently, and it requires no additional storage. On the other hand, materialized views store a physical copy of data in the database. The query result is pre-computed and stored, needing manual or scheduled refreshes to update the data. Materialized views are much faster for complex queries that are run frequently, but they require additional storage space for the data copy. In short, regular views are real-time but slower, while materialized views are faster but require periodic updates. Now let's look at how to create materialized views. Here's the syntax for PostgreSQL. You use the command, create materialized view followed by the view name, then as, and then you define your select statement with the columns, table name, and anywhere conditions. Finally, you specify with data to populate the view with initial data. For Oracle, the syntax is similar, but with additional options. You start with create materialized view, followed by the view name. You can then specify when to populate the view using build, either immediate or deferred. The refresh option lets you define how to update the view: fast, complete, or force. The on option defines when the refresh happens: commit or demand. Finally, you write your select statement with the columns, table name, and where condition. Key parameters to consider are build, which determines when to populate the view; refresh, which dictates how to update the view; on commit, which updates the view when source tables change; and on demand, which requires manual refresh only. Refresh types include fast, which updates only changed rows; complete, which rebuilds the entire view; and force, which attempts a fast refresh and falls back to a complete refresh if necessary. Refreshing a materialized view is essential to keep the data current. Here are a few syntaxes depending on your database. For PostgreSQL, the refresh syntax is quite straightforward: refresh materialized view followed by the view name. In Oracle, you can manually refresh the view using the dbms_w.refresh procedure, passing the view name as a parameter. For SQL Server, you use the exec command followed by sp_refresh view, again specifying the view name. There are multiple ways to refresh materialized views: scheduled refreshes, where you use database scheduling tools to automate view updates at defined intervals; concurrent refreshes, which allow querying the old data while building a new version of the materialized view; incremental refreshes, where you update only the changed data to minimize refresh time and resource usage. Let's explore some best practices for working with materialized views, the do's and don'ts. First, let's explore some do's. Use materialized views for expensive queries. Apply them to complex queries with multiple joins or aggregations that are executed frequently. Balance refresh frequency. Schedule refreshes based on data update patterns and business requirements for data freshness. Create appropriate indexes. Add indexes to materialized views based on common query patterns to further improve performance. Also, monitor performance. Regularly evaluate query performance and adjust materialized view strategies as data volumes change. Now, some of the don'ts. Do not overuse for simple queries. Avoid creating materialized views for simple queries that execute quickly from source tables. Do not neglect refresh scheduling. Always remember to establish proper refresh schedules, or your data will become stale and inaccurate. Do not ignore storage implications. Don't overlook the storage requirements, especially for large result sets that duplicate significant data. And don't refresh during peak hours. Avoid scheduling refreshes during peak system usage, as they can be resource-intensive and impact performance. Let's examine some common use cases for materialized views. Data warehousing is one, where you pre-compute and store aggregated business metrics for reporting dashboards, allowing for fast responses to complex business intelligence queries, summarizing large volumes of historical data, and scheduling refreshes during off-peak hours. Real-time analytics is another use case. Here, you create materialized views that update frequently for near real-time analysis, such as e-commerce tracking of current day sales metrics, financial systems monitoring recent transactions, or social media and website traffic analysis. They are also useful in distributed systems. Replicate data across multiple nodes in distributed database environments, reducing network traffic between database nodes, providing local access to remote data, and improving resilience with redundant data copies. Lastly, in API optimization, you use them to speed up API endpoints that deliver complex data to applications, reducing API response times for frequently accessed data, lowering database load for mobile and web applications, and creating specialized views for different API endpoints. In summary, let's recap the benefits of materialized views. They provide a performance boost by enabling significantly faster query responses by pre-computing and storing complex result sets. They contribute to reduced database load, lowering CPU and input-output usage on database servers by eliminating repetitive complex computations. They provide data consistency control, with controlled data freshness through scheduled updates, preventing stale data issues. And they result in simplified queries by creating abstraction layers for complex data models, making queries more readable. So, in essence, materialized views are a powerful tool to optimize database performance and simplify complex queries. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.